Hello, has Dr. Jitun sir joined?
Yes, yes.
Okay, thank you. Hello, has Dr. Shamsa joined?
Sham is mute.
Yes, yes, I'm here. Am I audible now?
Yes, sir, yes. Sir, can you please share your entire screen for this checking?
I'm just trying. Just give me a minute.
Okay, okay.
Is my screen visible now?
Yes, sir.
Okay. So this is now in full screen mode, right? Hello, can you hear me?
Yes, sir, it's in the full screen, so can you put it in the presentation mode? Like,
It is in presentation mode now.
okay, sir.
Is it?
No, sir, I think it is not still in presentation mode.
Just give me 1 second.
Okay.
Hello? Hello? ഞാനത് നോക്കൂ. Is it good now? Hello? Hello?
Good evening, sir.
Good evening. Is it good now?
Your voice is audible, sir.
No, the presentation is in full screen mode now.
No, sir, no.
No,
sir.
Let me just re-log in for a second, please. Hello? Hello? ഏതാണ് എവിടെയാണെന്ന് പറയാമോ? എൻറ്റയർ സ്ക്രീൻ എവിടെ? ഫുൾ സ്ക്രീൻ ആണോ? ഏത് ഓപ്ഷനിലാണ് വരുന്നതെന്ന് പറയാമോ? പ്രസന്റ് നൗ യെസ്. ഓക്കെ. ഒരു സെക്കൻഡ് ഹോൾഡ് ചെയ്യാം. ഞാൻ സ്ലൈഡ് ചേഞ്ച് ചെയ്യുവാണ്.
Sir, can you please change the slides?
ഹലോ ഹലോ
Yes, sir.
Sir, ഇപ്പൊ okay ആണ്.
Yes, sir.
സ്ലൈഡ് മൂവ് ചെയ്യുന്നുണ്ടോ?
Yes, sir, it's okay now.
Slide is moving, right?
Okay, fine.
Jitin sir, can we start?
Yeah, sure. So good evening all. Without any further delay, let me just introduce the chief guest for the day. It is my privilege to introduce the speaker of the day, Dr. Shyam Nair. Dr. Shyam Nair did his master's and PhD from Texas A&M University, USA. He did his BTech from College of Engineering, Trivandrum, Kerala. He is presently working as faculty in the Department of Civil Engineering, IIT Kanpur. He has several reputed publications to his account and is an expert in payment materials and engineering. We are honored to have Dr. Shyam Nair for delivering this session on full depth reclamation, execution challenges, and quality control. Since we are short of time, without any further delay, I invite Dr. Shyam Nair and all the participants to this program. Over to you, sir. Thank you.
So thank you very much. So good evening, everyone. This is Shyam. So today's presentation, I'll be looking briefly into various challenges that are faced, or some of the challenges rather, that I could come up with, or rather think about as an immediate problem that practitioners might encounter when they are doing construction work, and also some of the techniques that are typically used in quality control of these FDR materials actually. So I will start off my presentation with a broad introduction of FDR as such, because I don't want to get into the details of it, because most of you, I believe, are aware of what exactly FDR is. So I'll just broadly touch upon some of the things that are involved, and then I will get into the core part of the presentation. So this will be around 5 or 6 slides that I have on this particular area. So now when we talk about reconstruction, there are reconstruction or maintenance and rehabilitation, there are multiple ways in which it can be done. So the typical practice is like a building up option, which means that whatever is there, we try to build on top of it. Good example of that would be if you have a problem, you put a structural overlay on it, or any kind of like overlays of that matter. So now the problem in these cases is that some of the distresses that we typically encounter in case of pavements cannot be addressed, especially cases where you have some rutting issues, say base damage is there and base repairs needs to be done. Now, those kind of issues cannot be addressed properly when we are doing a build up or a structural overlay kind of an option. Now, there are other issues like the elevation of the road or the reduced level of the road raises above what was there. And you have other problems related to, the level differences with gutters, then overhead clearances in case of, under bridges and all those things. So those are some of the issues. Now, the alternate option that we have is to remove and replace. Remove everything that is out there and then build a new one. Again, a good option, but couple of issues that are there, like construction window is pretty long, which means that the road has got to be closed off for a longer period of time. Then a large quantity of virgin materials are required. So the cost obviously is going to be much higher in that particular case. Now, when we deal with the PMGSY roads primarily, or village roads, if I would use that word, these are many a times single point access roads. I mean, you don't have multiple access options for the residents. So closing it for an entirely long period of time may not be a very suitable option in this particular case. Now, the alternate option that is there is to recycle the existing ones, or rather I would call it as build down. Whatever is there in the pavement section, you actually use that and reconstruct your pavement using the exact same materials that is available to you. So this can lead to, again, a lot of benefits, as you can clearly understand. Some of the resources that are required, the quantity of resources required is less. Construction window can be very short because immediate strength to the section layers. So the construction window can be small. Then since the new materials that are being used is much less, it's a economically viable option as well. Now, the structural capacity of the road itself can be improved because it's an entirely new section that we are building, and we can customize it depending on our requirements at any given point of time. And on top of all these things, the additional virgin material that is required in terms of surfacing, which is typically what is practiced in case of PMGSY roads. Typically, we give about 1 to 2 inches of overlay BC layer on top of the existing or reconstructed FDR, which will cater the requirements in terms of surface protection and smooth riding comfort as well. So all these things comes out to be advantages of using this recycling option. Now, basically, if you talk about what is happening in there, now, let us say in the figure here, what we have is a GSB material. I'm adding cement to that, and I'm trying to compact that into a CTB is an example that I've been using in this case. Virgin materials, the modulus that you get because of while using a GSB material is somewhere of the order of 200 MPAs, whereas once you convert that into an CTB or a stabilized layer, you are looking at numbers in terms of 15 to 1800 megapascals, which means you have a much stronger layer. Advantages: the stronger the layer is, if you look at the picture here, once you have a unstabilized layer, once a vehicle travels on top of it, there is going to be significant deflection because the underlying layer is not very rigid. So because of those deflections, you may end up having fatigue damage in your HMA layers because every time it's flexing, so horizontal tensile strains accumulate at the bottom of your HMA layer, and the failure is going to be much faster, which actually does not happen once you have a cemented layer because the surface layer is not going to be flexing very much, and as a result of that, fatigue life of the bituminous layer is improved significantly. Now, the same applies in case of rutting as well, because you have, in this particular case, you have unstabilized material. So the load that is being transferred by the vehicles is distributed localized fashion, which means possibility of having a subgrade damage is going to be high. Whereas in a stabilized layer, as you can see here, the same load is distributed in a much wider area because of the rigid layer, or rather a semi-rigid layer that you have in between. So the rutting issues can also be addressed by using this recycling technique. Now, in terms of stabilizers, the typical choice in most of these cases that we are dealing with right now is cement. It's not mean that other stabilizers cannot be used. If you look at the table that is given here, what I have on along this horizontal row is the different type of soils that so basically soil classification. And what I have here is the different options that can be used. Let's say if you look at emulsified asphalt, then what you can see is that as you move towards the right on the screen, they are more clay soils, and the one on the left is more like granular. So emulsified asphalt options works very well when the soil that we are dealing with is more of a granular texture. And as you, if you can look at the lime part here, the lime is effective when you have the soil that is more of a clay type. Simple reason is that as a result of that, the strength gain can be achieved. If it is a non-clay material like granular material, the strength enhancement with lime does not work out very good. So how do you do that? You can estimate the utility of a given stabilizer by looking at the PI values of those soils. Say, for example, if the PI is more than 20, then lime can be an effective solution. If it is less than 6, then you can go with something like a emulsified asphalt option. Now, the main point here is that if you look at what is applicable for cement, it is more or less applicable for all granular materials as well as for certain level of clay content that is present in soil. If the clay content is extremely high, then we may have to switch to a lime option. But in normal soils that we encounter, the PI is not going to be very high. So cement universally becomes a preferred option in this kind of a process. Now, in the case of reconstruction, once we go about in terms of selecting an FDR, the first thing is that to check whether the given road is going to be a good candidate for FDR purpose. That's the first thing that we have to do. Now, more or less, if you look at it broadly, then what you can say is that any road that is meant for reconstruction can be a good candidate. Now, roads that has got seriously damaged and cannot be completely rehabilitated by simple resurfacing, that's a good road that you can select for this option. The distress levels, it's going to be very high. There is going to be areas which has got significant amount of base and subgrade damages, again, a good candidate. A road which has got a lot of patching, say, for example, 15 to 20% of the road is already patched up, which means it already had some level of distress, that can also be selected. Now, if the structural capacity of the pavement is not good enough, then yes, you have to, instead of giving a much thicker section on top, you can actually choose FDR as an option and go ahead and improve the structural capacity. So in case of exceptions, more or less, one of the things that you have to deal with broadly is whether the road is going to have any kind of drainage issues. Now, the problem with water being present is that it can negatively affect the strength gain process when cement is added. And also it can deteriorate the properties if the cement has already given it enough strength. The introduction of water can actually cause deterioration of those strength properties. So whatever we do, if we have a drainage problem associated with a given section, it is always better to address those problems first, and then you think about choosing FDR as an option for that particular candidate road. Now, the other thing that needs to be careful about while selecting a road is to see if the road has got some, geotextiles, geogrades, or anything like that, which is already present in the road. If a road has got these geotextiles, then it is ideally not a suitable candidate for FDR. Simple reason is these are textiles or sheets or layers, and what we are doing in this process is to remix the entire material that is there. That includes the bituminous layer, then the base layer, and the soil as well. So when you are using a reclaimer or something to mix up these three layers, a geotextile layer in between can negatively affect the mixing, proper mixing of these layers. Again, mixing of the in situ layers, mixing of cement with these layers, and also it can cause damage to the machine that we are using. So all because of these, if a pavement section has got a geotextiles or a geogrid in there, it is ideally not a very good candidate for FDR option. Now, in terms of process, I know that you already know about all these things, but just to recollect, we are actually working with existing HMA layer, existing base layer, and a part of the subgrade layer. And the process involves multiple steps or multiple stages. We can rather call it as a train because it's a continuous process where stabilizer is dispersed first, then it is going to be followed by a spreader that spread out the materials evenly across the width of the pavement. Then recycler along with the additives or chemicals or water comes in, and it actually mixes up the whole materials together and add the required additives and water along with it, followed by a set of compaction approaches, like static compaction, then shift foot rollers, and all those different kind of compaction, which I know that you guys are familiar with that. So I'm not going to the details of that. So a simple pictorial representation of various steps are given. Cement drying is there. Water injection, a truck is following that. It's in the front of the machine. Then there's a reclaimer that is running along with it. Then you have pulverization, which the reclaimer does, followed by grading that you have to do, and various levels of compaction. So this is a typical process. Now, starting off into the challenges that are faced in FDR execution. Now, many of these things kind of feel very rudimentary for you, but these are significant enough to affect the timely completion of any given FDR projects. Now, the first thing is that identification of utilities. Now, this is one part that creates problem in practically every construction work that we perform, especially recycling, in-situ recycling like FDR. Now, the problem here is that these roads that we are working on has been there for quite a long period of time. And different types of utilities have gone through it, and it has been covered up by the existing surface. So when you look at it from the top, it will be very difficult for us to identify these ones. This could be examples like water lines, then there will be drainage lines, it could be electric and telephone cables, whatever. You can think of all these things. And all of these has got to be relocated before we start the actual FDR work. Simple reason is we are going to use about a 25-ton reclaimer that is going to be standing on top of this, and it is going to be mixing up the road surface altogether, road depth altogether. So all these utilities need to be reallocated before we actually start the construction work. And the real problem is that the data related to what is going where, nobody has any idea about. And if you ask any agencies, then identifying these locations is going to be practically impossible. They don't have any information about what has gone into there. This will include what the different agencies have put in, what household people have put in, connection lines, all those things are going to be there, which need to be identified on site. Now, on a practical sense, if you look at it, if you have horizontal crossings of utilities, then it is very difficult to identify, because once we start off this process, we'll be taking trial patches or trial pits, and longitudinal utilities like water lines or drainage lines or sewer lines, those can be identified easy. But if there is something that is horizontal, then it will be very difficult, and we need to be careful while we are doing the reclaiming process to identify these. And at least even if we have to stop the work, we need to relocate them before it can be completed. Now, there are surface utilities as well. If you look at it, manholes are going to be present. There are going to be electric poles, because many a times we might be widening the road as well, along with strengthening it. Say for example, a 3.5 meter road has to be widened to a 5.5 meters. So obviously all the electric lines, electric posts, all of these things that are abutting the existing road section, which many a times, as we see, is going to be very close to the pavement section. So they all need to be relocated, and before the work can be executed. Now, saying that is pretty simple, but removal and realignment, it's a difficult task to do, because in Indian conditions, it's not managed by a single utility agency. Different parties, different people as stakeholders in that. Say, for example, drainage department, then electricity boards, and all those people, different agencies are stakeholders. So interagency coordination becomes a very significant factor. Again, it will happen, but time is of essence, and many a times this can actually delay the progress of the work. Now, along with that, there is end user interest, because the people living here, they are the actual users of the road. Somebody might be having their house in front of it. They don't want to have a water line that is, relayed utility that is placed in front of their house, because if something happens later, if it breaks, then the whole area is going to be, excavated and reconstructed, which is going to be a difficult thing for them. So they might ask you to actually change it from this place to that place. So these kind of stakeholders, let's say if it's a shop owner, then he might have his own preferences in terms of certain things. So we will have to accommodate all these things while we are relocating this. And in fact, bottom line is that this can lead to time extensions and many a case cost overruns, which unfortunately cannot be completely estimated prior to the start of any given project. So only after the work gets awarded, the area has been allocated, then you start looking at this. And this has got to be done very as early as possible, because a delay, this can take time. And uh, so the process of identifying these utilities has got to be done in the very beginning. So now the other problem that we typically face is that the depth of existing pavement many a times is actually higher than the FDR thickness. Let us say typically what we do in terms of FDR thickness is about 25 centimeters. 20 to 30 centimeters is something that you can reasonably think. Now you might end up having different kind of pavements, existing pavements. If you look at the one on top, there is going to be a very significantly thick bituminous layer on top, and the bottom one has got a very thin layer. Now, thin layer is not much of a problem because we are adding cement to it, whereas a thicker section can be a problematic case. Now, the reason why it becomes problematic is that cement has got less binding with the bituminous materials. Now, the cement gains its strength from by reacting or interacting with the soil and the granular materials that are underneath the existing pavement. So interaction with cement, interaction with soil, or interaction with granular materials, that gives the strength. Now, if you have a bituminous layer that is almost like, let us say, 30 centimeters thick, and you want to perform an FDR of 25 centimeter on it, you are at best, I mean, you are staying within the HMA layer itself in terms of your reclaiming process. So no soil available, no granular material available. So if you use a certain amount of cement, it will not provide you the required strength that you are looking for. So in that case, what you have to do is you may have to come back and mill and remove the surface layers to a certain depth. Let us say, for example, you are trying to construct a 25 centimeter thick FDR layer. Bituminous layer already is 30 centimeters. The best option would be you come back and mill out about 20 centimeters of your, HMA layer and replace that. I mean, take it out of the construction site. So that may be required so that FDR can be effectively done. Now, what this brings around is cost overruns, unprecedented cost overruns, because these mill materials has got to be transported, that has got to be disposed in a proper site, which can also be costly. That space can be kind of like a few kilometers off of the project space, so transportation cost is there. Then time that is required for this milling activities is up and above the time that is allocated for the construction work itself. So this is one problem that is typically encountered in these construction sites. Now the other one is different layer thicknesses. Now, as you know, if you take a 5 kilometer stretch on a village road, you might end up having a small section like half a kilometer which has gone through significant amount of damage, and some agency has come in and actually did a couple of overlays to address this problem. Now you take your samples for your material testing from the section before that, and you end up being in that particular section, then your entire bituminous layer thickness is different, which means that the mix design that you have prepared using the first location sample is not going to be very effective in this particular case. Now, that is one problem in terms of thickness. Now, the other thing is that difference in layer compositions. In Uttar Pradesh, many of the works that we do, one thing that is commonly observed is brick bats. Now, people put brickbat layering on it, and top of that, bituminous layers is actually placed. So because of that, you may end up having brickbats in there. There might be boulders that has been put in the very initial phase of the construction of the road. Then there could be different aggregate sources from which they have collected materials and used it. The soil types can vary with respect to locations. So all these things has got the mix design that you are using has got one way or the other, so that uniformity is maintained all the way through. Let's say if you have a multiple layer thickness of HMA layer, because of the overlay, you can actually mill out some of those sections and take it out. That can solve your problem to bring it back to the original mix design that we have actually prepared. Or in certain cases, you may end up requiring more than one mix designs as well. So all these things need to be identified as part of the DPR preparation stage itself, so that work can go on smoothly. Now, one of the other problems that we typically face is realignment issues. Now, if you look at many of these old roads, they may have multiple curves. They are not designed to maintain a certain specific speed. So once you're reconstructing, you cannot just go back and do the same thing, because speed limits and the speed requirements have changed. If you want to try to make a 50 or 60 kilometer speed roadway, then of course the realignment of the road and the smoothing of the curves have got to be done, which means that the curves needs to be straightened in many areas. So that brings in its own challenges. There are super elevation issues because the curve, the super elevation is different, then the material configuration or the layer configuration is there different. Then you have centerline shifts. If you look at the figure here, the centerline itself has changed. Or even in this case, you can see the same thing. Now, all of a sudden, when a centerline changes, then what happens is that materials, what are the existing road, depending on which we have made the mixed design earlier, is actually falling out of the centerline. So which means that those materials needs to be shifted because of the issues can happen. Then cut and fills can emerge. Now, realignment brings into a cut section, so all of this has got to be cut and removed, and there might be places where filling has got to be done. Has got to be identified. See what is coming up. After preparing your alignment, you have to revisit the location and make sure that many of these issues that has been and has now shifted. So the existing road has got to be brought back to the center line, and they have to be dispersed again for FDR process. So that requires additional money, then additional efforts. So in certain cases where it is not at all possible, we may have to consider the option of constructing with new materials, say like GSB. Let's say if you are milling out the whole existing road, it is going to be very similar to a GSB material. It has got granular materials in there. It has got fine fractions in there. So instead of moving the whole road itself, you can do the FDR process, or rather it is going to be more like a CTB section, but still very similar in terms of the process. So GSB can be laid in that particular stretch where the realignment has happened, and it can be stabilized again. Now, another problem that you typically encounter is longitudinal grade issues. Longitudinal grade corrections need to be made to maintain the safety aspects, to maintain the speed requirements and all those things. So fresh materials or fill materials needs to be brought up. You have to buy new GSB materials to lay on top of the filled areas. So all those can actually come in case of issues related to longitudinal grade corrections. And this is going to be a significant, if it is there, it's going to be a significant quantity and cost-bearing quantity. So it has got to be accounted for as a part of estimate preparation. Now, the other problem that typically comes across in case of FDR is problems with subgrades. Now, you might encounter soils which has got very high plasticity. That is, like as I've discussed earlier, if the plasticity goes about 20 or so, then cement may not be a very good option. So this may not be something that you see always, especially if you are working in areas of agricultural areas, say for example rice paddies. The clay content in those soils are going to be quite high when compared to something that is there in a residential area. So those kind of things needs special attention, and again it can only be addressed in a site specific manner. Now what happens is that when clays are present or high plastic clays are present, they absorb water, and when they absorb water and cement, once it is put along with that, and if you try to mix it, mixing is not going to be uniform, and as a result of that you might have sections which has got very high strength, very low strength. So it will be a mixture of all those things which cannot be upfront predicted. So that problem will always be there, and it has got to be addressed in a site specific manner. Next thing is about organic content. Again, if you're agricultural areas, rice paddies, you may end up having soils which has got a very high organic content. Now, if the organic content goes anywhere above 1%, then cement or any kind of stabilizer does not work very well. A good representation of that is given in the figure here. You have the compressive strength and you have the organic content of soils in an increasing fashion in the x-axis. Now, what you see is that as the organic content increases for a given mixed design, the strength properties of that soil actually goes decreasing. So that is one problem we have to keep in mind when we are dealing with organic soils. Now, next problem is not something that is very obvious in every place, but it is always better to check it out. Now, this is a problem related to presence of gypsum or sulfate in your subgrade soils. The problem is that if sulfate is present, it can lead to swelling of those layers after construction. once water becomes available. So now if something like a heave that you're seeing here on the figure happens to your road, it's going to be completely damaged. But again, the good part is that this may not be encountered in all the places. Say if you have a area which has got a lot of rainfall, an arid climate, a lot of rainfall, and the soil is quite porous, pervious, then these can dissolve in water, and over a period of time, the sulfate content will be very low. But if you are looking in some clarish areas, if that's got to be happen to be a gypsum source that is present, that will still be available in those places because it is not going to be that porous. So it will still remain on that, and those areas can actually have this kind of a problem. And broadly speaking, generally speaking, if the sulfate levels, if you are looking at it, anything below 3000 milligrams per liter, that is a concentration estimation of sulfates. If it is less than 3000, then there is not going to be much of a problem. Now, one of the other things that you typically encounter is related to shoulders. People have come up and said that shoulders are not required. Well, it actually contributes to the structural strength of the road itself, simply because it can avoid edge crackings, and it will stop the vehicles from going off the road, and as a result of that there is going to be a differential a cantilever kind of an action on the roads, or rather it is going to be non-uniform kind of loading that is going to happen along the edges, and it can lead to edge crackings. Now the other problem is drainage options. Many a times we work with road sections which are limited by right-of-way availability, and provisions for drainage is many a times ignored because of cost constraints, because of right-of-way issues, and all those things. So you have to make sure that there is no waterlogging in these areas, and also a reasonably good drainage provision is available. Either it is a constructed one like a concrete drains, or a brickwork drain, or even an earthen drain that can effectively remove the water from going underneath the pavement section. So once water comes in, then you are going to the challenges is on the administrative side. Now, this is related to payments that are made in construction. Now, if you think about this whole process, this is going to be quite expensive in terms of construction materials that is being used. Then the machinery that you are using is going to be hugely expensive as well. So any delay in terms of payment making can actually lead to a huge financial loss to the person who is working, the contractor basically. So if I give you a ballpark number, an ideal set of machineries lying in a site over a period of 1 month can cost the contractor near about 25 to 30 lakhs. That's the loss that is incurring if a machine stays idle in a construction site for 1 month. This is a ballpark number, can go on and off depending on what all are there. So ideally, that is why I have added, along with the train that you have seen earlier, I have added a money truck along with that, which means that as the work progresses, the money has also going to go along with it. So then only the work can be a successful one, and otherwise it can lead to issues related to litigations and all those things. So there are cases that we have encountered because of this issue as well. Now, administrative side, there are other things that you have to look around, that is managing your work packages. Now, how much of a work has got to be awarded to a given contractor. Now, it should be such that it is going to be cost effective for him, and also it should be something that is manageable. Now, if in Uttar Pradesh, initially what we have done is that every package that is given to one particular contractor was up and around 30 kilometers, not a single stretch, at different adjoining areas, wherein the equipment can be mobilized easily from one side to the as we go along. These are also quite